Alaikum wa rahmatullahi ta'ala wa barakatuh. Hello my dear students, and this is our new lesson on exercises on the last unit in geometry, which is unit 3 maybe. Now it's unit 5. And page 96, let's open our box on page 96 and let's start with number 3. In the opposite figure, ABCD is a parallelogram with BC equal 15 centimeters and CD equal 8 centimeters as we see in the picture, or as we see in our box, and we have the diameter or the diagonal equal 19 centimeters, and we want to prove that triangle ABC, where's ABC, yes, is an obtuse angled triangle. Yes, that means that angle ABC is an obtuse angle. Yes, I'm hearing someone saying, yeah, we can get the squares of the three sides and compare the longest one with the sum of the others. So we have 19, yes, this is the diagonal, and we have 15 centimeters. And what's the length of AB? AB, because ABCD is a parallelogram, so AB equals CD, which is equal 8 centimeters. That's very good. So now we want to find the squares of the three sides. So we want to find the square of 19. Yes, we want to find the square of 19 and compare it with the sum of the squares of 15 plus 8 squared. So 19 squared, which is equal 361, and 15 squared, which is equal 225, and 8 squared, which is equal 64. What is the result of 225 plus 64? So it's equal, yes, that's very good, 289. Yes, what's the relation between 361 and 289? Of course, 361 is more. So the triangle is an obtuse angle triangle, and the angle B, ABC, is an obtuse angle. Okay, let's move to number 4. And number 4 says, find the length of BC and triangle ABC, which AB squared more than AC squared plus BC squared, and AB equal 15 centimeters, AC equals 13 centimeters, and ED perpendicular to BC and intersects at D, where AD equals 12 centimeters. So let's draw a triangle which is named as ABC, but be careful. Why? Because AB squared more than AC squared plus C squared plus BC squared, so it's an obtuse angle triangle. Yes, and the longest side should be AB. So you're going to draw an obtuse angle triangle, and the longest side we will name it as AB. Yes. So ABC. Okay, and C is the obtuse angle. And now we have AB equal 15 centimeters. Yes, and we have also AD perpendicular to BC. Yeah, if we want to draw a perpendicular line segment from A to BC, so it will intersect it outside the triangle. That's very good. And then we have AD equal 12 centimeters. Where's AD? Yes, 12 centimeters. That's very good. Also, we have AC equal 13 centimeters. So it's equal 13 centimeters. And we want to find the length of BC. Yes, we want to find the length of BC. How can you find the length of BC? Yes, I'm hearing someone saying we have a right angle triangle, so we can calculate the side which is named BD. That's very good. And we can calculate also the side which is named CD. So from triangle, the right angled triangle which is named ACD, we can find that this is 12, yes, and this is 13. So 13 squared, which is equal 169, should equal 12 squared, which is equal 144, plus CD squared. So CD squared will equal 169 minus 144, which is equal, yes, that's why I got 25. And this is CD squared. So CD equal 5 centimeters. So CD 5 centimeters. And now we're going to find BD. Yes, the whole of BD. Yes, so in triangle, in the right angle, the triangle which is named the ADB, by Applying Pythagoras theorem, we can find that 15 squared, which is equal to 125, equal 12 squared, which is equal 144 plus PD squared. So it's equal PD squared. So PD squared will equal PD squared will equal 225 minus 144, which is equal, yes, that's very good, which is equal 81. So BD without squaring equal 9 centimeters. So the whole of BD equal 9 centimeters. So BC should be equal 4 centimeter, and this is the length of BC. That's very good. And now we're moving to number 7, page 96. ABCD, the triangle is a rectangle as shown in the figure. ABCD is a rectangle in which AB equals 30 centimeters. We have AD, where's AD? AB, yes, AB equals 30 centimeters. And AD equal 40 centimeters, AD which is equal 40 centimeters. And DE perpendicular to AC, yes, and intersects it at F and intersects BC in E. Find the lengths of EF, DF, and CD. We want to find the length of EF, where's EF? Yes. And DF, where's DF? Yes. And EC, where's EC? Yes. We want to find the lengths of EF and DF and EC. So listen to me very good and concentrate with me. We have the side CD equal the length of the side AB, which is equal 30 centimeters. 30 centimeters. And by applying Pythagoras theorem, we can find that AC equal 50 centimeters. The length of AC, which is equal 50 centimeters. And if we want to find the length of DF, we can find it by applying Euclidean theorem. So DF should equal 30 times 40 divided 50, and that's equal 120 divided 5, which is equal 24 centimeters. That's very good. So DF equal 24 centimeters. And then if we want to find the length of DF, where's DF? DF, oh, that's right, we found the length of DF. We want to find the length of EF. EF itself, EF. So EF is a projection of the side AD on the hypotenuse AC. And we can use Euclidean theorem also. So we can say that 40 squared equal AF times 50. So AF should equal 40 squared, which is equal 1600 divided 50, and that's equal, so AF equal, so 0 can be cancelled with 0, and we have 3 and 2. Again, 5 by 2 equal 10, 5 by 3 equal 15 plus 1, which is equal 60. That's by God centimeters. So it's equal 32 centimeters, which is AF. So you want to find also CE, but before we find CE, yes, we can find what? We're going to find the length of FC. What's the length of FC? So as the whole of AC equal 50 centimeters. And we found that EF equal what? Equal 32 centimeters. So a CF equal 50 minus 32, and that's equal 18 centimeters. So it's equal 18 centimeters. But CF is perpendicular. Please concentrate with me. CF is perpendicular to the straight line DE, and the angle C is right angled. So we can apply Euclidean theorem, and we can say that CF squared, which is equal 18 squared, equal FE times FD. Again, FE times FD. What is the length of FD? We found that. Yes, it's equal to 24 centimeters. So it's 24 centimeters. So we want to find FE. So FE equal 18 times 18 divided 24. And we can divide by 6 by 4. That's very good. We can divide by 3 by 8. Okay. So divided 6 equal 3. Divided 6 equal 4. and divided 2 equal 9, divided 2 equal 2. So 3 by 9, which is equal 27. 27 divided 2, which is equal 13.5. That's very good. 13.5 centimeters. So FE equals 13.5 centimeters. So we can find the length of DE. So DE equal DF. Oh no. Again, yes. We said that CF is perpendicular to AD and the angle C is right angle, so we can apply Euclidean theorem. So CF squared equal EF or DF by FE. So 18 squared equal DF, which is equal 24 by FE. So 18 squared equal FE by 24. By dividing the two sides by 24, we can find that FE equals 13.5 centimeters. Yes, divided 6 equals 3, and divided 6 equal 4, and divided 2 equal 9, and divided 2 equal 2, so 9 by 3, which is equal 27, divided 2, which is equal 13.5. So we want to find the whole of DE, so DF equal 24 centimeters, and FE, which is equal 13.5 centimeters. So 24 plus 13, and that's very good, yes, 37.5 centimeters. So 37.5 centimeters. And we can find the length of CE by applying Pythagoras theorem inside the right angle triangle ECD. Yes, and that's equal the square root of 30 squared minus, no, it is not 30 squared, that's very good, it's 37.5 squared minus 30 squared, and we can find the value of it by using calculator, and you can find it by yourself. Yes, by applying Pythagoras theorem. 37.5 squared, yes, minus 30 squared, you can find the length of CE. And that's the end of our lesson today. Thanks so much.